Ciao, Andrea.
Ciao, Nan. How are you?
Very nice to see you.
Same here.
So today my guest is Andrea Lodi. He's the Andrew Hage and N.R. Tisch Professor at the Jacobs Institute at Cornell Tech and the Technion, as well as a member of the OR and Information Engineering field at Cornell University. His main research interests are in mixed integer linear and nonlinear programming and data science, having a significant publication record in the most prestigious journals and conferences of those fields. Andrea's work has received several recognitions, including the IBM and Google Faculty Awards, and he is the recipient of the Informs Optimization Society 2021 Farkas Prize, which is right there. He serves in leading editorial positions, most notably, he's a co-editor for Mathematical Programming and an area editor for Informs Journal Computing. He has been the network coordinator and principal investigator of two large European Union projects, and in the period of 2006 and 2021, he acted as a consultant of the IBM CPLEX research and development team. Andrea is the co-principal investigator of the project Data Serving Canadians, Deep Learning and Optimization for the Knowledge Revolution, and the scientific co-director of IVADO, the Montréal Institute for Data Valorization. Andrea, it's a great honor to have you here. I'm so happy. Thank you so much. ¿Cómo estáis? How are you?
It's my pleasure to be here. I mean, I watched some of your very nice interviews with some other colleagues and friends. So it's good to be one part of the crowd.
Yeah, it's fantastic. So you're born in August 1969. Tell me about your family background and how was life during the 70s and 80s?
Well, 70s in Italy were actually, I would say, a difficult time from the political circumstances. I mean, terrorism has been not a great time for Italy. Been political opposition left and right at the worst possible situation. But in terms of me being a kid, at that time, it was wonderful. I mean, living in Bologna, which is quite, let's say, a advanced city from many perspectives in terms of the university being there, so having a lot of cultural life, and definitely the 70s were a time in which we thought it was possible to achieve anything, also in terms of equity between diversity groups and so on and so forth. So for me, it was actually a very nice time.
Right. And what about your parents? What did they do?
So my parents were not in academia, I would say, at all. But my father was working for a bank. My mother was actually stopped working when the kids arrived, like a classical Italian family at the time. It's not that anymore. But I have a sister that is actually quite older than me, so 10 years older than me. But we have. It was an interesting, as I said, a time to be a kid with a lot of freedom, I would say, in terms of going around the neighborhood, meeting friends, coming back home only when our mothers were actually shouting on us.
Playing in the streets too?
Yeah, playing in the streets, actually doing a lot of sports. So I was a very sport-oriented type of kid. So I liked to go to school. I mean, clearly I was enjoying math and a lot of other things, but I mean, pretty much everything in school. But at the same time, I was enjoying really staying outdoor as much as possible with friends. So the number of cars at the time in the neighborhood was limited enough to be able to play in the street without actually that to be too dangerous and also to be stopped. We were playing actually tennis against the wall in the street. And we were actually annoyed by the fact that from time to time there was a car stopping forcing us to stop playing, which I think now would be like in the area in which my parents used to live, would be like I don't think that they can play that form with the number of, actually, first of all, the number parked in the street, and in addition, the number of cars passing by. So that will not be compatible.
Right.
But I have very nice memories about that.
Uh-huh. Did you play other sports? You mentioned tennis, and you were a sports-oriented person. So I wonder which type of sports you enjoy.
Of course, I'm Italian, so I was playing soccer in the street most of the time, to be honest. And I was playing. Mostly I was swimming. I did quite a lot of. Later on, I started playing tennis quite intensively. But then when I moved to high school, the sport at the time in the 80s in Bologna was basketball. So there were two teams in the top positions in the league. They even played the championship final, one against the other. I think they played the semi-final of the European Cup,
wow.
One against the other. So it was called Basket City, and everybody was like crazy about basketball. So I played basketball for maybe 10 to 15 years, and then until the time in which it was better to actually do some less contact type of sport. So I went back to tennis, even if I still play soccer from time to time with my friends.
Wow. I don't know if you remember Oscar Schmidt, a Brazilian player that
of course
was in Italy.
Of course. That was the time exactly when Caserta was actually like a big team as well. So and Oscar was playing for Caserta from the south.
Yeah.
Yes, absolutely.
Right. Did you study in a public or private school, and were you a top student in your class or just an average student?
I always went to public schools. So, in Italy, I would say that most of the people that you may know went to public schools. Is a bit of an exception going to private schools. The public system used to be, and I think still it is, quite good. And I always say that I was a good student. Yes,
good.
I was a good student.
Did you have any heroes or any specific figure that inspired you in those days?
I don't think so, but what I know is that in mid school, so in Italy we have 13 years of school, right? Mm-hmm. 5 elementary school years, 3 years of middle school, and 5 years of high school. And then we go directly to university, different from many other systems. So in the middle school, I have this fond memory about our science and math teacher that she took a student, a university student in physics that was actually preparing his master's dissertation about teaching physics to kids. And then so we spent for 3 months or even more. Every one of the lectures was actually doing experiments in physics with weight, volume, all these kind of related things with them. That was actually try to give us the classical scientific method. So step by step to get to prove something that you want to achieve. And I have a very fond memory about that time. I think that the interest in science, and especially my appreciation versus the scientific method, has been forged at that particular time. So I couldn't say that it was my hero. I don't even remember exactly the name of the person that was there, but I definitely I found some time ago a nice picture of us doing these experiments and so on. And I always say that this is probably was my inspiration at the time in terms of becoming, let's say, a scientist, for sure.
Yeah, yes. That's great, and you should post that picture eventually, maybe on Twitter.
I should find it again. So I moved from different places, and I don't know anymore exactly where it is, but if I find it back, yes, maybe.
Excellent. What were your main aspirations and dreams while growing up?
Yes. So I think it's important to say I grew up in the 70s, clearly, but I make a point that I born in 1969, which is the year of the man on the moon. Yes. So I think 95% of the kids of my generation, we wanted to be astronauts, right? I mean, we wanted to go to the moon or something like this. So I don't think I had, I mean, I personally believe that I'm doing my dream job, but at the same time, yes, if it was one thing, that would probably at the time I was really like inspired by doing that. And the first time I went to visit the Space Center in Houston.
Johnson Space Center.
Yes. So then I went to also the Kennedy Space Center in later, a few years later, in Cape Canaveral,
yes.
but in Florida. But when I went to Houston, I honestly spent like a day. I was probably already maybe 40 or 35. I don't remember exactly, but it was like a kid in a candy store, right? I mean, I was like so excited about everything that was going on there that people were looking at me a bit like, wow, this guy must be very passionate.
I can totally relate because I felt more or less the same. I visited both too. And it's a fantastic experience for those who love, this type of things. Any special reason for choosing the electrical engineering degree?
Well, technically, I wanted to stay in science, and definitely, so I was tempted to go in physics, to be honest, at the beginning, which I think it was a very good decision, because when I went to engineering, I realized that I was not really understanding physics very well. But engineering was at the end was like the right place to be. I had a friend that in high school, his father was actually a professor in my department, in the department in which I became a professor of, and so he took us to visit the university, gave us a speech, so on, at the time in which he was about to decide. And at the time, electrical engineering was actually like everything that was related to information was actually engineering was in the department. So the department that was called DEIS at the time, so DEIS, then it became DEI, so DEI, was including, graduating in electrical engineering was meaning like you can take a major in electrical engineering, but also in computer engineering, or actually in a certain sense in a mathematical engineering, which was actually what I did mostly with Silvano Martello and Paolo Toth.
Yeah, and how and when OR appeared in your life?
Well, the third year of university. So at the time, before the Bologna reform, so we had 5 years of schools of engineering, and those 5 years were actually split into the first 2 years that were like basic science, a lot of different things, including, of course, computer science, but also mathematics and so on and so forth. And then the third year, we started to pick the topics that you really were interested in. And when I attended the first couple of lectures of Silvano Martello as a professor of operation research, so the basic course of operation research, I definitely fell in love with the topic. And so at the time, I mean, I couldn't be luckier than that. So not only Silvano was actually the professor in charge, but actually Matteo Fischetti was a young fellow, and he was doing the exercise. I mean, like additional lectures, like exercises and so on and so forth. So I picked from both of them, and then I took the course of Paolo, and eventually that was pretty much clear for me that I wanted to do the master thesis with Silvano and Mauro Dell'Amico, that was actually at the time also around, and then later it was a step, kind of a natural step to go into OR as a PhD student and so on.
Right. You mentioned some big names there.
You aware? Superstars. I would say superstars. So that you learn from the best people. That is, I told you. I mean, we were discussing about this, but I mean, it's definitely like I consider myself very lucky, right? I mean, I've been I had the best, I mean, among the best people that you can think about for to get inspiration from, both as a teachers, as scientists, and so on and so forth.
Mm-hmm. Were you aware of the importance of the superstars when you were starting?
Not clearly not. No, it was pretty clear that Paolo was so much respected by everybody else in the department that it must be somebody in a certain sense that was playing a role. But no, not really. I mean, you realize it. I started to realizing it when I did the PhD, because of course, I mean, there were books, papers, and then you start studying papers. And everything, and you go to meetings and you realize how much these people are actually important for the community. Mm-hmm. So yes, at that time, but not at the time in which I was a student. No.
Yeah, you mentioned that pursuing a PhD was a natural path for you, but when did you actually realize that you wanted to do a PhD?
So since it was 5 years, so roughly speaking, we believe that it's like a bachelor and master program at the same time. So more or less that was currently is the situation. So now it's split into 3 years plus 2 years, and then these are separate. And then at the time doing a master thesis, it was taking 6 months. So I was actually having a very good long project. At the end, we wrote a paper about what I did into my master thesis, I found it very, very interesting, right? I mean, it was about math, CS, this computer science at the same time, implementing the thing. It was a very creative, and at the same time, the interaction with the other people, the other people in the department was very pleasant. The professors was always very relaxed, but at the same time, having the impression of doing something meaningful.
Mm-hmm. Very nice environment.
That's very nice environment. So I told myself, I kind of considered it to be at that point, a kind of a natural choice.
Right.
Well, without understanding exactly what it was, in a certain sense. So it's a natural choice to take 3 more years to study. In Italy was 3 years. Uh-huh. And but the fact that was leading to stay in academia and so on and so forth was again not totally clear at the time. So it was partially the case, but not totally clear. Yes.
Mm-hmm. What about the famous corridor? Can you confirm the story told by Manuel Iori, who was here as a guest last year?
Yeah, it's totally true. I mean, we grew up in the corridor. We were sharing. This essentially open, now they're calling it open space. For us, it was just being the corridor because it was not designed to be an open space with desks. The desks were added because of the fact that there was this chronicle lack of space, and so the students were actually sitting in the corridor. So when I joined, Alberto Caprara was already in that corridor, and then I actually took a little bit of his space, and then there was Juan José Salazar was actually visiting. He was not exactly there at the time, but visiting multiple times and sharing with us the corridor. And Alberto was already a PhD student at the time, and I was actually a master student, and then I stayed as a PhD student, and then eventually we moved to the office. This was actually a part which was almost in front of Paolo Toth's office, and then we moved to the office very nearby, and then we kept that space for Michele Monaci later, for Manuel and Iori and a few others. Eventually, we found more space later, and then they went down. So, but I mean, that was the group staying there, yes.
You mentioned so many great names. I think we should call that a corridor of fame, right? Instead of Hall of Fame.
It was definitely an interesting. I think Manuel mentioned that all the students or everybody passing by the department was stopping to ask information, right? I mean, asking, where is the office of this one and this one? For me, that is totally true. The main memory about this is that we used to recognize exactly the people, so the usual people, so the other professors in the department, by the way in which they were actually walking, right? I mean, we were listening to the walk of somebody coming behind us, and we say, "Oh, Professor Calzolari is going to his office," right? I mean, and then it was just because we were so much used to this that it was clear. And at the same time, I had this memory about so when I started traveling a lot. So at some point, I was in an airport with stuck somewhere, and I started coding. I had my laptop on my luggage, and I was actually coding. I should try to write some code, and somebody told me, "Wow, I mean, this is actually can you concentrate in these circumstances?" And I told this person, "Well, I mean, sure, that is actually a piece of cake.
Yeah.
It's a reasonable environment to concentrate." And so in order to actually write, debugging your own code and so on and so forth, under this situation with everybody passing by, asking questions, noising, walking, and actually having conversations and students waiting for an appointment with the professors, that was clearly like a good place. So if you could resist to that, I mean, we not recommend it, but it helps in some type of circumstances. Yes.
Yeah, it's a great story, and guessing the people based on their steps is pattern recognition and its best, right?
Yes, probably, yes.
And you were quite known for your vast work on integer programming. However, you actually started your research career working on heuristics for packing and assignment problems, right?
Yes. So that at the time, so in Bologna there were several topics that have been very important and on which the group gave great contributions, especially the original core team. So at the beginning was definitely the knapsack problem, but when I joined, the Silvano and Daniele Vigo were actually very much involved into extending essentially the work on one-dimensional packing into two-dimensional, three-dimensional packing, and that was my topic for the PhD thesis mostly, especially at the beginning. Then and then I did, a little bit of meta-heuristics, bounds, models. But then over time, the situation was like, at the time, only Paolo and Silvano were supervising students. So which means that we had a limited number of students, like one student at a time. So when I was the student, or together with Alberto, mostly we were actually looking at one or two problems at most. But we had multiple people to interact with because of Paolo, Silvano, Daniele, but also by the fact that there were Matteo was still kind of very connected, Mauro Dell'Amico, and so over time I was involved in many things, and then everybody found his own path, and
right.
because indeed Paolo, Silvano were actually very open for us to, finding our own way.
And what made you turn attention to integer programming?
Well, Matteo, I would say that Matteo was the key inspiration for turning my attention to integer programming, where I really found the thing that I wanted to do the most, because it was very connected to general purpose methods, so being able to implement things that were actually making a difference within solvers like CPLEX, or writing code, but at the same time doing methodological work, and so I found that was the thing that was actually inspiring me the most, and definitely I got it from Matteo. Yes.
Right. Another positive aspect in Bologna is that you had the opportunity to meet great names that eventually visited the university. Do you remember some of them?
Oh, well, you can't be more true in saying that. I mean, I have this very fond memory of I was indeed sitting in the corridor at my desk, and then Paolo comes out of his office and says, "Andrea, I'm very busy. These are the keys of my car," okay? Which is already like intimidating. And these are the keys of my car, and you have to you go picking up Egon Balas at his hotel.
Wow.
And well, I was actually half understanding what I mean, probably I was more worried about driving Paolo's car than to go to meet Egon. But that was actually what was happening. So Egon Balas was regularly coming to spend a week in Bologna, maybe teaching a few lectures in Paolo Silvano class. I mean, Giancarlo Lestra was another one. Dori Dogbaum was coming very regularly. That was like that was
Disneyland.
Seriously something. Yeah, seriously Disneyland. Yes.
Yeah.
Yes. And yes, and I really drove Paolo's car, pick up Egon, brought him. Got him to the office on time for his talked to him, and that was the beginning of a very nice relationship that I had with Egon, and that was. Egon was the number one storyteller and in our profession, plus a superstar, of course.
Absolutely.
In the profession,
right?
In the profession, but I have those memories.
And let me tell you, Nelson Maculan, who was also here last year as a guest, he told that the driving skills of Professor Egon Balas was not the most developed, if you will. So I think it was better if you drove the car, probably. So we could get
especially in a city like Bologna, which is not as complicated as probably as Rio de Janeiro, but still it's narrow streets and so on and so forth. Definitely, I think I was helpful at that time.
Yes, this experience of meeting big names when you're still young can be very inspiring. For example, I remember the first time we met about 14 years ago during the Brazilian Hour Conference here in João Pessoa, my hometown. I was in my first year of my PhD, and you were one of the keynote speakers of the conference. And at some point, Sheila Zochner, the secretary of Sobrapo, which is the Brazilian Hour Society, told me to take you to the local market to buy cashew fruits. That's because I was living here. Of course, I was already doing PhD in Niterói, but it's my hometown, so I knew where to take you. And moreover, I remember that later you even attended my presentation, and you were very supportive after the session, and that had a great impact on me. It was probably the first time I was getting a direct feedback from a distinguished international researcher. And so after all these years, Andrea, I would like to thank you for that very kind gesture. And,
Well, so thank you for saying that. To be honest, the situation is, as I said at the very beginning, so I feel very lucky. I've been very lucky. Growing up as a scientist in Bologna, as a student first, and as a scientist, let's say, during the PhD later. And I try to give a little bit back. So in the sense that I try to go to places doing PhD courses, try to talk with the young people as much as I can. And because I feel like I was lucky to have this. Sometimes if you are if you're not in those big places in which things were happening, so like Bologna was one of these places, especially if I think about Europe, then you have much more feedback than you can have from
absolutely
becoming a scientist in other places.
Yes.
And I think this is something that I have to give back to the community. So I tend to say yes when I'm asked to. It's a pleasure, right? It's not that I feel obliged to do it, but in any case, I also feel that it's part of my being part of the community to partially give back what I received at the time.
Yeah, and we thank you for that, for sure. After finishing the PhD, you quickly found a position in Bologna itself. And how was the transition from being a student to becoming a professor?
Very natural in a certain sense, because at the time, indeed, there was like the evolution of the group was very linear, right? It was, they were actually, at the time, Paolo and Silvano had the position, Daniele had a position, Alberto had a position. So eventually one position has been created because the group was growing, and I was the right place in the right time, and it was not a big transition to start teaching myself and being more independent, especially because as I like to, as I partially told you before, that we have been given, complete independence from the very early days. So if you think about the people that have been growing in the group created by Paolo and Silvano, so everybody got his own, let's say, specialty, right? I mean, like personality-wise, he or she was actually with Valentina able to actually later on define themselves in a specific area. So for clearly Matteo was one case, that Mauro Alberto was actually more in the approximation side. I was more in integer programming. Daniele clearly took the applied side to the top limits and so on and so forth. So I think that was not a big transition in the sense that we stayed in a good environment, and I was already I had already enough freedom during my PhD for doing the things that I really wanted to do.
Right. In a recent presentation, you mentioned that MIP solvers are composed of main 4 components, namely preprocessing, cutting planes, branching strategies, and primal heuristics. You put a lot of effort in devising efficient procedures for each of these components. Could you mention some of your main contributions in this context?
Well, I pretty much believe that I spent my entire career in trying to improve each one of these steps, but definitely the starting point, which was the work on heuristics that you were mentioning. Mm-hmm. I mean, I moved from heuristics for combinatorial optimization problem to heuristics for general purpose MIP, like I mean, mm-hmm. with local branching and the feasibility pump. This has been a long-term interest for me, and in improving that was again partially because motivated clearly by Matteo, but it was partially because my own experience when I started running CPLEX, which was 3.0 mm-hmm. at the time. Mm-hmm. For the people doing computation in MIP, so there was the column of the feasible solution, so the primal bound. Uh-huh. This was never populated, right? I mean, you stayed for hours with the dual bound moving nicely, and the primal bound was essentially empty, and that was quite annoying. And
no gaps, right?
No gap, because there was no primal solution. Yeah. But and so when I think that the contribution of populating that column, not of course by myself, or but with giving some contributions in that direction, and picked up by the CPLEX people with several methods and many others, have been a very nice time at the beginning of 2000, in which there was a huge amount of activity on this area, and I think that was nice. Now I'm picking back this. With my work on the integration of learning methods with discrete optimization and MIP, and I have a student that is actually looking at these things mostly, and Matteo joined this effort again. Mm-hmm. So we are having fun looking back at what we did at the time and try to improve at on the lens of, as the people say, in the lens of the machine learning perspective. Mm-hmm. But of course, cutting planes has also been quite a lot of my interest in slightly later than the heuristics. But again, as you said before, so there were these 4 components. I pretty much tried to I feel that I started with the local branching. I feel that I never stopped. Right? That was every single aspect that was interesting for me.
Uh-huh. Yeah, local branching, as you mentioned, is one of the most popular methods that you have proposed. And how did you and Matteo come up with that idea?
Well, this is also an interesting story. So I think, at least for me, it's very interesting. I think that was coming from originally was coming from some work on set covering that Matteo did. So like, but in a combinatorial context. Then he proposed me idea, and in order to explain me the idea, of course, the easiest way to do it was actually like thinking at like a 2-opt, 3-opt, k-opt for the TSP, right? I mean, that's the classical way to think about it. And then we started to think about this, and then I know for sure that Matteo and JJ, so Juan José, have had a very initial version of this sometime before. But at the time in which we realized we took it, I mean, we took it to the level for writing the paper, was the time in which we realized that there was a chance of solving, at least heuristically, mixed integer programs by themselves, right? I mean, in a certain sense, the idea that is behind the scene is that you can take you can model your problem, your neighborhood as a MIP, and try to use CPLEX or your favorite MIP solver to actually, I mean, partially solving the problem, at least finding solutions for the problem, provided that you give it that is concise enough, small enough, it's well defined with the local branching constraint, so it's actually giving you some traction or a grip, as Matteo would like to call it, probably, in order to get into this. So this is the beginning. So I believe that JJ has implemented some version maybe a couple of years or 3 years before, and it didn't work. But I think it was because it was not the right time, right? I mean, in a certain sense, the time in which it was possible to use a MIP solver as a black box, it didn't come, was not mature at the time. But I also remember very well that when, I mean, we discussed about this in actually, I think in Sardinia during an IRO conference, so the Italian OR conference. And then I came back, I implemented this, and I gave a call to Matteo in the evening saying, well, I mean, I got, I think it was actually the best known solution at that point for Seymour, so the famous set covering instance in the MIP-lib, I don't remember which one. And so we had to check that it was actually correct because nobody knew about a solution. I think the solution was, if I remember correctly, was 423, and I don't think it was known that there was a solution of 423. And I got it in like a couple of steps of a basic local branching implementation. So we were like, wow, that's something going on here.
Yeah. Right, excellent. Yeah. You acted as a scientific advisor for CPLEX for so many years. Could you share more details about this long-term collaboration?
Well, that was again like being a candy store, right? I mean, it's for me it was like when they asked me to join as a part-time member, as a consultant in a certain sense. I mean, that was like, well, these people are doing history, building the software that was, I mean, honestly, I mean, led to a different level of our ability of solving mixed integer linear programs, and then I can try to use it in, I mean, seeing if my ideas can get into the software, being helpful for improving a lot. And I actually, my intimate understanding of mixed integer programming is based on the possibility of actually collaborating with so many great people in the CPLEX team over time. So it's has been a very, very nice journey.
Again, right place at the right time?
Well, very much so. I've been collaborating with many people, I mean, super strong people, like starting from GU, of course, Rothberg, so the people that then later went to Gurobi. But I mean, I had the chance of working with many great people, like clearly like Tobias Achterberg, more recently with Pierre Bonamy has been, and I developed a nice connection with these people. It was a very, very nice time.
Yeah, yes. That's excellent. Do you still code, or do you have a favorite programming language?
Unfortunately, I don't code very much anymore. For my teaching, I became a bit familiar with Julia and Jump, and
Yes,
I mean,
I also
way
use
of,
that for teaching. Yeah.
but not really. I don't have the time to actually. I don't have enough enough amount of continuous time to devote to actually writing the code myself. So that's been like something that I'm missing, because it was a very nice time. But no, in the last probably 10 years, I haven't been doing this very much.
Yeah, I perfectly
Probably
understand
a
you.
bit less, but yes.
Yeah. As you move on in the career, you tend to have less time to code. And
Well, it's a matter of, at some point it's the way in which the profession evolves. In a certain sense, the point is that you have other responsibilities, and this responsibility makes allow you to build a team and having students, and you feel like that's the job that you have to do. But this means that there's also like a time in which it's hard. I mean, there are still people my age or even older that they do code actually quite a lot. I mean, Jeff Linderoth was here in New York for 6 weeks during his sabbatical, and he was so happy to be able to, during sabbatical, to spend really a good chunk of his time in writing code. So maybe the next sabbatical I can try to do that.
Yeah. Why not?
But I mean, I used to actually, again, the first type of project that I did were in Fortran even. Then I switched to C, and most of the things that I've done in integer programming are in C.
Yeah.
And just recently I'm doing something else.
You also seem to be very active in the constraint programming community. In which cases do you think that combinatorial optimization approaches can benefit from constraint programming?
Well, that was a time, especially in Bologna, in which there was a big group doing this. Michela Milano was actually the person that was mastering this and building a group related to this. Michela and I were actually undergrad students together, so we grew up together when we did the PhD. Actually, she did it in CS, I did it in math, but or whatever. So in any case, art. And so it was clearly like when the wave of constraint programming started and the connection with mathematical programming, that was I wasn't again maybe in the right time at the right place, and so there was natural for me to actually start looking at those things. It was fun. I believe that there was more hope of a stronger integration, especially when CPLEX, when actually I log both CPLEX at the time before the IBM time. So the idea of putting these two things together was actually more. In a certain sense, there was more hope. At the same time, I think this integration has been happening quite a lot. So if I think about many methods that have been developed for the preprocessing side of MIP, they are largely overlapping with constraint propagation and all this area. At the same time, the constraint programming solvers, which were originally like a pure type of methods, they became a very hybrid codes and algorithms that are solving a lot of MIPS internally. Of course, people like Pascal van Henterik have been the masters and the inspiring figures in doing this kind of integration. I would say that if 20 years ago Pascal was considered a constraint programming person, now I don't think anybody actually has any doubt in considering 100% mathematical programming person, and this shows that many people have really realized this type of integration fully.
Yeah, excellent. Ruslan Sadikov was here as a guest last year, and he highlighted the importance of recognizing the efforts of developing optimization software. For example, when one is applying for a job or a grant, publications tend to attract immediate attention, while the potential impact of an open source code or software might be overlooked. What's your take on this?
Is sadly true. Even if there have been steps for correcting this, for example, inspired by, I think, Martin Grötschel at the time, my friend and colleague Bill Cook has built Mathematical Programming Computation as a journal. MPC became a very respected journal in the area that publishes also papers that are, mostly computational in a certain sense.
You have to submit the code or provide the access for.
So there have been multiple steps. So now not necessarily the code, maybe an executable. It's on the other hand, I can see the reverse thing as well. So now journals like Operation Research, Management Science, they are requiring you to contribute the code at the end in order to, with a sort of a reproducibility perspective. They don't look at the code itself, but as the code has to be available. So I think there is there is an improvement. I think that it's definitely true. The people doing computation or developing software, it's not. I don't think it's totally. It's only for our field. Even in the machine learning context, in a certain sense, the people that have developed open source type of projects and so on, and maybe, for example, those that took it to the highest level is because they work into companies for which this is important. Like, you think about Google and so on and so forth. Otherwise, it's actually maybe difficult. But at the end of the day, I will recommend, to be honest, I would recommend young people to do, I don't think there is a recipe for that, right? If you're really passionate in writing software and you want to take it to the best and doing that, I think that you can find your own way if you are good and if you are passionate with that. So I have plenty of examples. There are prizes for implementations, like the BOH prize from the MOS Mathematical Optimization Society. So at the end of the day, if a young person is I always recommend a young person to do what he or she feels it's actually following
passion.
The passion.
Yeah, excellent, absolutely. There has been some criticism regarding the difficulty of using optimization tools when compared to AI and machine learning software, thus preventing some OR methods from being widely used in practice. What's your opinion regarding this matter?
It's a $1 million question. So we recently had a workshop during the AAAI conference about partially motivated by the constraint learning and other things like this. So the interaction between AI and operation research. So of course everybody kind of says this. So it's still hard to come up with a good discrete mixed integer programming model and so on and so forth. But my take is that these are NP-hard problems, right? There should be some difficulty in solving them. Otherwise, that's not. Everybody can write a valid MIP formulation, but not everybody can write a formulation that is solvable by a mixed integer solver, right? That is the end of the. More or less, that is the situation. So can you automatize the fact of writing very good formulations? There have been steps over time, and there are let's say positive use cases in which things have improved. But on the other hand, some inherent difficulty must be related to the fact that the problems are hard, and so you need even more research to actually get into this. So that is my take on that.
Yeah.
But I mean, the fact that there are people that are trying to do that, I feel that is definitely possible. And I mean, the comparison with AI methods is a bit particular, because the point is that the AI method or machine learning methods are delivering you a statistical output, right? I mean, it's like a probability that something is true, or some, let's say, predictive
is this a cat or not?
And this is, I mean, like everything that is statistically done, I mean, you can prove very complicated and very and beautiful mathematical theorems about this, but at the same time, in practice, it is going to be used mostly as a statistical tool for getting insight. So in math, in OR, I mean, true or I mean, right or not right, we're also trying to prove optimality, which requires on NPR problems some more less statistical and more mathematically oriented type of approach, in my opinion.
Okay. At some point you moved to Canada. What made you take that decision?
Well, that was like an opportunity that was impossible to miss. So this position that I had for 7 years, my chair is about to finish at the end of June of this year. Is like the dream job for a scientist. So the government gives you a quite
generous amount
amazing, I would say more than generous. I would say amazing amount of money for building a team, and you are put in the best possible conditions for doing this. I mean, essentially, you hire students without, thinking if you have a project or anything, because you can build it on the way. And in addition, I was again at the right time in the right place, in the sense that we the idea of having this chair that was running on the integration of, or actually the interaction between machine learning and discrete optimization was actually designed inside the University of Montréal, Polytechnique, and HEC, so the business school. They have been, let's say, kind of adventurous in giving this position to me, but that was meaning that I could collaborate with, again, superstars, top scientists, people in OR, superstars in the people that build the profession, like François Soumy or Michel Gendreau and Gilbert Laporte, plus all the young generation, Louis Martin Rousseau and all these people, Jean-François Cordeau, Emma Frehinger, and so on, plus all the beautiful environment and very inspiring environment like Yoshua Bengio, that Yoshua Bengio created over time, in the machine learning side. So, of course, nice, very, very good place to be at the time.
Great. In recent years, the interplay of machine learning and combinatorial optimization increased substantially. For example, one may use optimization procedures to improve the accuracy of machine learning models, sometimes providing interpretability, whereas machine learning approaches can be employed to improve the efficiency of exact and heuristic algorithms. How far these two lines have evolved, and what are the main challenges to be addressed?
They have taken, at the time in which I started to do it, there was no community, and I think the community, there were a lot of people doing this independently. Now there is a community, so every conference in machine learning has some stream in which those papers are well received. There are workshops, there are summer schools, and so on and so forth. So that's a big step. From the scientific perspective, we are at the second level. So we have first we had to show that you can learn in the context of mixed integer programming or vice versa that discrete optimization methods could be useful for. But there were more proof of concept. Now I think that the step to be achieved is to put these things into production. So we have been together with my student Giulia Zarpellon and Pierre Bonamy. We've been able to actually having the first implementation of a learning algorithm that is now integrated into CPLEX is in the full version for deciding about linearizing or not a mixed integer quadratic optimization problem. This was a big step. I think that now Gurobi is doing something on other parts. For sure, Express is doing this for other things as well. Skip has stuff like this. So there are some technical issues which are, for example, a lot of the good methods in learning methods are based on neural networks. Neural networks give their own best on GPUs, while we do everything on CPU. So the relationship, even hardware perspective, it's not easy. The learning methods, for example, for discrete optimization are evaluated over accuracy, which doesn't tell you much about the performance of the optimization methods they are applied to. I mean, there have been a lot of research on trying to do more integrated methods. I mean, the big step could be doing reinforcement. If reinforcement learning wants to move from let's say gaming, so Go and Atari games, to actually something which is really like applied. I mean, no offense, of course, for Atari games, but the point is to really solve applications. And then, I mean, one important case study could be like try to make it working for difficult problems in discrete optimization, like, for example, branching. So, for which it seems to be perfectly designed, but I mean, the reward techniques require quite a lot of evolution. So I think that there are plenty of questions on the table, but the good news is that we are already at a point in which we have to show practical relevance, right? I mean, it's not anymore like a proof of concept. I think it's practical relevance, and we start to see that relevance.
Yeah, that's very nice to hear, very encouraging. And I honestly hope that more progress can be made in the very next years. So Andrea, some authors from the machine learning community have attempted to solve classical combinatorial optimization problems such as CVRP using all sorts of learning procedures. I have noticed that many of them simply don't compare the results produced by their methods with state-of-the-art optimization-based algorithms. I personally believe that this sometimes can be misleading, can yield misleading conclusions. What is your impression on this? Do you have any recommendations?
Well, I recently wrote a paper with Daniele Vigo and one of his students, Luca Corsi, about that. So we have a paper on, I think recently published on Operation Research Letters, with giving some recommendation on try to use learning methods for the CVRP, because I don't think that the community, I mean, the way in which we're comparing computational evaluations is not aligned. So we don't do the same things. So that is certainly like an issue. I understand it. I'm not a CVRP person, but at the same time, I feel the frustration of some of those people having spent quite a lot of time, like you, the Brazilian crowd, I would say, the fantastic group in Brazil. So the frustration of seeing like almost like reinventing the wheel, but without comparing with the real wheel. So yes, it's a matter of, I mean, this is one part of the creation of the community that didn't happen yet. But for example, I spent quite a lot, if I can tell you, I spent, in the last 2-3 years, I always said yes to be a member of the, I mean, not the program committee, but in the machine learning conference like NeoRIPS. So or ACML, you agree to be a referee, right? I mean, you get some papers and so on. Especially because I wanted to learn on my side what are the trends and so on. It was very useful for me, but on the other side also to play some role of saying, well, wait a second, so this has been compared with something that is not realistic, right? I mean, and so on. So at the same time, coming back to your point about open source and whatever, of course, the drawback is that some of our methods are not open source, or they not used to be open source. And so, I mean, this opens the door to the fact that maybe the machine learning community will say, well, I cannot compare with that because it's not open source. I cannot use it, right? And so I think there is some effort that has to be done on our
that's a very fair point. Yeah.
Side as well, in order to make this to bridge this gap.
Yeah. I know that paper. So this question was not coincidence.
Okay. Good.
Yeah. So let's talk about IVADO, the Montreal Institute of Data Valorization. You are one of the co-founders of IVADO Labs. Tell me more about it.
Well, these are two different things. So IVADO is indeed an research institute in a certain sense. So it's federating the effort in the originally Montreal. I think now they changed the name to Quebec Institute of Learning of Data Valorization. Has been funded for building for essentially using the generous funding given by the federal government on the thing that you were discussing at the beginning, so data serving Canadian. So we applied for as principal investigator, co-principal investigator together with João, Benjo, and we got this a generous amount of money from the government in order to actually make sure that the community was actually getting this at large. We built the institute, and it's been my privilege to be the co-scientific director with João. And this has been a very nice journey, interesting, but mostly on the research side. Like there is a little bit of technology transfer that is associated with, let's say, research projects between companies and academia. But what we realized over this effort was that when some of the companies, in order to have more AI methods, when we say AI at large, learning, discrete optimization, everything that is goes from what informs call prescriptive and predictive and prescriptive analytics, needed some, let's say, more consulting arm with respect to academia, right? I mean, when a company gets together with an institution like University of Montréal, they have to agree on pretty much everything, and before that, you can start the project. If it's if it's something that has to go into production, essentially, then the company is interested. Or when you're done, the company already is interested in something else, right? I mean, it's not that doesn't go at the pace of that. So that's the reason why we built IVADO Labs, that is a consulting company that try to indeed use the academic experience. We have 12 scientists that we're giving 1 day a week to this and having, but this is a more professional perspective. So it's something that has been certainly useful, because also the government of Canada essentially granted some money to this institution called Scale AI to favor projects in AI for supply chain, and so some of those projects are taken by IVADO Labs as essentially as a company. Like it's doesn't really have to, let's say, building a big agreement. It just has to find the good project to work on and jumps on it.
Okay, right.
Just by professional activity, if you want. It's a little bit more professional than that.
Right. You have an extensive editorial activity. By the way, congratulations on being appointed as a co-editor for Series B of Mathematical Programming.
Yes.
What have you learned over the years, and do you have any interesting stories to share in this context?
Well, this dates back. When Daniel Kuhn, that became the NP mathematical programming editor in chief asked me to be the co-editor in charge for MPB, has been like closing the cycle, because this was my first initial first job as in the editorial team. I've been asked to join mathematical programming as associate editor back in 2004 by Bill Cook, when he was the editor in chief. So I've been with almost 20 years with the mathematical programming. Is my, I say that's the home journal in a certain sense. So it's very good to be still there. I mean, I learned a lot. I mean, you have. I think the point is we sometimes all are frustrated by how our papers are treated by referees, by journals, and so on and so forth. This is inherent, so structurally associated with the fact that this is a volunteering type of job, right? I mean, I'm spending a lot of my time for just because I want to give, in a certain sense. So of course, is prestigious in a form, but it's certainly much more work than the prestige that comes with it.
Time
so
consuming.
It's the fact that it's very time consuming, and the point is you try to do it because you feel like it's important to keep the publication process running in the way in which you feel it's important that it has to run. I can tell you that there have been some time in which the contribution that I feel I gave is that sometimes there was a short phase in which one classical approach for evaluating computational papers was like, okay, you're try to run, so the referee could tell something like, oh well, you compare with CPLEX. If you are slower than CPLEX, then your method doesn't work. And this has been fortunately rejected as a methodology for evaluating a paper by the community, and that's the reason why there are editors, associate editors, and so on and so forth, because sometimes the referees, in a good faith, they take shortcuts, and we need to be there. One needs to be there for making sure that there is a picture, that there is a let's say there is the full picture is actually realized. So you need as an editor to have a clear picture of what you want to achieve, and I think this is important. And it's not clear that my picture is better than the picture of somebody else. That is the reason why I'm going to serve as a co-editor for 3 years or whatever, and then somebody else is going to take over. So the point is that it's important that we take turns, but at the same time, I think it's important that journals are managed in this form, and the people are devoting their time in to keep the process running.
Okay. The amount of complex activities you are involved is really impressive. How do you manage time, and what do you do in your spare time?
That's a very good question. So, in my spare time, I try to still do some sport. So I play tennis, and nowadays mostly, not much soccer in the US so far, because my best soccer mate, Oktay Goluk, is now in Ithaca and not in New York. Otherwise, I'm sure we will find a way. But I have a colleague here that for which we probably want to start playing soccer with our students at Cornell Tech, but here in Roosevelt Island. So I like a lot to go to movies, theaters, museums. Of course, being in New York is a great location for that. I like food a lot, so I like going to nice, as you experienced. So I like to go to nice restaurants, and then, I try to spend time with my family. I still have part of my family in Italy, so I go back. I travel quite a lot back and forth, and that's time consuming, but of course good. And the fact of being involved in many activities is. I don't know. I cannot give you an answer that is actually clean enough, in the sense that some days is overwhelming, and I would like to keep to reduce it very much, and then some other days I feel that's right. I mean, it's already my type of life, and so I should keep going. But you should probably mostly ask my students if they are frustrated or not getting enough attention, which so far I don't have. I mean, I have. I don't have such a bad indication that that is happening. So I think I still got a relatively decent balance on that.
Right. Yeah. You have changed countries once again. You just mentioned that you are now in New York. So now you are in the US to write the next chapters of your life. What can we expect from Andrea Lodi in the coming years?
That's hard to say. So I will. I mean, I'm pretty sure that I will continue to play with mixed integer programming for the rest of my life. But here there is quite a lot. I mean, first of all, it's my first job in a private university versus a public university, which is not necessarily like an easy step. I mean, I came here as a tenured professor and everything, so it's not like a technical difficulty, but it's an environment. It's changing. Things are changing. I'm enjoying it so far, but definitely is a change. In terms of science, I would say that I mean, here there is quite a lot of activity on urban tech. So like. If you want smart cities, and I mean the university has been created. This campus has been created with a lot of connection with the city of New York in order to, I mean, try to help also in making New York a better place to live. And there's a lot of proudness about New York, right? I mean, being in New York means means a lot to many people, and it's nice. And I think that I will try to give a contribution in this direction. So try to see if some of the things that I'm interested in are applicable to this environment, and we see. I mean, it's definitely, you're right. I mean, it's a different chapter. Currently, the previous chapter is still going on, in the sense that I have many students left in Montreal that I don't want to feel that they are left. So I need to be there in many perspectives. But at the same time, I mean, there are new challenges to be looked at. I think that there is this vast. I mean, one of the things that I care the most at this point scientifically is that. We are at the time in which we can look at. I mean, definitely there is this nice area about explainability of the methods, which has been, I mean, an old and new problem at the same time. But also there is what I care the most is more about the fairness, right? I mean, we're talking about resource allocation. Discrete optimization is resource allocation to a vast extent, right? I mean, making decisions that are impacting the life of people. I mean, allocating resources, doing things in such a way that there is an impact on the life of people. So I think fairness is a fundamental area in which I think research should go. I mean, a lot of people before me have done this in a much better way, but I think I became to a point in which I reached a point in which I think that there is some stuff I could potentially do, and I've already started a little bit with some of my friends and colleagues. So I think this is one area in which definitely I'll try to see if I can still give some contributions.
Right. I wish you the best of luck in that endeavor. So, any plans to return to Italy?
I still have quite a lot of connections there. In this, I'm currently teaching a PhD class. I have a partial appointment at the University of Bologna after 6 years of being completely out of the loop. I was on leave, not returning to Italy, I think, as a permanent home. But I mean, I try to see if to exploit some connections between Cornell Tech and Cornell and University of Bologna to see if there is some chance of doing things together. So yes, I have some plans, but I mean, moving back to Italy I don't think it's going to happen anytime soon. But but it's too much moving.
Yeah.
But I still go quite a lot. So that's which is good enough in that sense.
Right.
Plans to go to Brazil, to come to Brazil. Actually, I should plan to come to Brazil for a little while.
Okay, so we can arrange you a nice office somewhere here by the beach. You know João Pessoa, so you know it's
beautiful. Yes, beautiful.
So you can always come and stay with us.
Yes, I miss. I mean, the last 2 years have been terrible for everyone. So I don't think that the in a certain sense that the fact of not being able to travel was the main thing, because everybody had bad experiences about the pandemic. But definitely what makes being a scientist special is that you are able to see your colleagues over time, establishing a relationship which are very strong over the job, and the travels that we do together has been let's say definitely sad not to see many friends around the world. So I am looking forward to start again.
Yeah, and I hope to see you soon here in João Pessoa. It was a great pleasure to have you here, and I cannot thank you enough, Andrea. It was wonderful to hear your views on many our topics, and also to learn more about you and your life, having this better picture of your profile. So, grazie mille. Thank you very much.
Obrigado. Thank you very much.
Yeah. So, Andrea, hope to see you soon. Ciao. Bye.
Thank you. Thank you very much.
Yeah. Bye.